So guys, let's go on to the ESP8266 diagram with the circuit diagram. Now, as we can see, here is our ESP8266 on the breadboard, and the connections we have made to this is done by jumper wires. You can buy these jumper wires, and the cost of each component is given in the README file. It will not cost you more than the specified for a particular time period. Later on, the price might vary. It might increase or it might decrease. Here is the ultrasonic sensor which we have placed onto the breadboard, and here's like the pins like trigger, echo, ground, as well as the VCC, which is the power pin. So what we'll do is we'll first connect the power pin, like the VCC pin, to the VCC pin 5.5 volts here. Thereafter, after connecting these to the power volts, then we'll connect the ground ones to the ground, the pins with the jumper wires. I've made like the same color connection for each kind of, for example, red color for the power of VCC, the ground is from, the brown color, and so on. Similarly, here the lights you can see I've according to the code which I've like used. Then there's this green color which denotes the trigger pin for the green light, both the green lights. The the purple jumper wire is for triggering the red lights. Then we have these blue and yellow. These blue and yellow are the like trigger and echo pins of to the ultrasonic sensor, which are connected to ESP8266, like the ones which will send input and output, and accordingly the function will be done. So here is the basic circuit diagram which we'll be working upon, and this is how we'll be going through the working of our smart traffic light system. And it is very necessary to follow this connection so that you can easily able to implement the functionality of ESP8266 as well as ultrasonic sensor. You might be able to make different kinds of connections as you please if you're able to go through this functionality once you're done with it. But other than that, if you want to like implement it or make it more complex, you can use even better components like Arduino Uno or like Raspberry Pi if you want some higher functions in which you might include an OS. But here we do not require all this, so we are using the simple basic ESP8266 along with ultrasonic sensors and traffic lights. So guys, here we have the code of ESP8266, and we'll be learning on how to implement MQTT protocol using Adafruit. At first, we have defined the Wi-Fi ID and password. Thereafter, we have server front and server port, right? Then we will be using the key and username which will be defined onto the Adafruit UI. After that, we can, just call onto the on off button and like, subscribe to that particular identity which we have created on the MQTT Adafruit. Then we'll be having trigger pins, right? D1, D2, D3 and D4, and accordingly we'll be having the red and green pin as we will be going over to the diagram and seeing it later on. Then we'll be looking onto the duration and distance variables. Then we'll be defining like which pins are for input and output. After defining the pins for input and output, we'll be going over to the status of Wi-Fi, whether it is connected or not. After getting the status of Wi-Fi, we can finally move on to the actual functioning, where we'll be getting the value and triggering the ping for a bit with a delay of 10 microseconds. After getting the trigger pin delayed by 10 microseconds, we'll be checking for the pulse, right? If the distance that has to be calculated and the value of that distance comes out to be less than 10, that means some object is near that ultrasonic center, we'll be triggering the red pin, that is the red D6 or D6 pin, which is here we can see the red pin, right? So accordingly we will be triggering it to high, and then after a certain time it will be again triggered back to low if the distance is greater than. Similarly, for we'll be doing that for green as well. If the distance is more than 10, that means the green will be triggered to high, and after that the red will automatically the red will be triggered to low if green is high. So this is how we'll be implementing MQTT protocol by connecting it to the server. And
So as you guys can see, now we're gonna work on ESP8266, which we'll be using in our traffic light system, right? So here we have the ESP8266 module and the power cord, which is gonna upload the code, and it has a Wi-Fi module which we have already connected to Wi-Fi by providing the SSID as well as the password. Then here we have the 4 pins, VCC, power, trigger, echo, and the ground pin, which we have connected to the ESP8266 pins, right? Thereafter we have the lights LED. One is for power, which will be connected to the trigger pins, and the other will be ground, which I've made the whole this line as ground in the other board, right? Here this whole line is ground. So as you can see, this ultrasonic sensor will automatically work when it senses something, and it will send the duration using pulse and function to the ESP8266 module. And when the duration will be calculated, what will be done is, using the formula, we'll calculate the distance. When the distance is calculated, we'll check how much distance it actually is. If the distance is less than 10 centimeter, for example, then the light should turn to red. For example, if a train is coming, and it will sense it that the train is nearby, and it is like 10 meters or 10 centimeters using bigger sensors with better sensitivity, it will automatically turn the traffic light to red on railway crossings. So this is how it will work, and as I've already demonstrated the code and the circuit diagram of how to connect it, you can also find it on my GitHub profile, the code as well as the functioning of the ESP8266. Here, for example, the code, the pins I've declared, the input output pins, as well as the connectivity, Wi-Fi using MQTT protocols. We'll using publish and subscribe in Adafruit. We can create a UI for which remote access, so that we can actually create a better performance of this smart traffic light system.